Hey folks, Mr. Anderson here one more time today to talk 912, section 912 in our CPM Common Core Algebra book. And today we're going to talk about a new and big idea that maybe you've seen before, maybe you haven't. And this big idea is called the quadratic formula. And it is another opportunity for us to develop a approximate or exact solution algebraically should something not be factorable when we need a solution and maybe graphing is not an option, because sometimes graphing gives us a very inexact solution, or even an exact solution if we have technology, but maybe that's not available. Okay, we're going to start with some modified notes here. I'm going to start with 9-12 from our ebook from section 912, and we're going to begin by kind of rehearsing how we can write a couple of things using what is affectionately dubbed as perfect square form. This is very, very similar to vertex form or graphing form. It's not the exact same thing, but it is this way for the purposes leading into the quadratic formula, this thing that we're about to come across here. Okay, it says a quadratic equation can be written in perfect square form by completing the square. Write the following equations in perfect square form, then determine the number of solutions for each quadratic equation. You don't actually need to solve. I'm going to kind of talk about the solution without exactly solving. And then, of course, we are going to explain how we can quickly determine how many solutions the quadratic equation has once it's written in perfect square form. So here we go. I'm going to just really focus on A here. And the way that we do this in perfect square form, recall, is by completing the square. And we do this by kind of creating a void, really sending that integer value over to the other side, and then really making an effort to complete the square. So I'll remind you of this. I'm going to write it as x squared minus 6x plus some number that I don't even know yet. And then I'll write this as 3 minus 10. Now it's 3 minus 10 because I took that and sent it over to the other side, and it was plus 10 on the left, so I'm subtracting 10 from the right. Okay, and that's the way that we create that movement. Now, how did we complete the square? Well, remember, I was setting this up, and here's my quick little sketch. I have an x squared, and I have 6x, and I broke those 6x up into x and x and x. I had half of them here and half of them here. If you don't recall this process from our completing the square video, you're going to want to go back and look at that. But the key is that I was cutting those things in half because I wanted it to be a square. And remember, ladies and gents, a square has a base and a height that are the exact same. So I had to take that 6, I had to cut it exactly in half. And then the question was, how many tiles was I adding there? How many tiles was I adding there to both sides? So let's go ahead and talk about that. How many tiles would fit in there? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to be adding 9 here, and in order to make this math work out, I would have to add 9 to the other side as well. So let's go ahead and do that, and we're going to rewrite this. And I've got x squared minus 6x plus 9. Now, the right doesn't need to look this gross. We can do some simplification here, and when I do so, it becomes very quickly 3 minus 10 is negative 7, and negative 7 plus 9 is 2. Okay, so that looks great. Okay, but I want to write this in perfect square form. Okay, and when I write this in perfect square form, it becomes x and x. This over here on the right is going to still be 2. And the question is, what two numbers multiply to be positive 9 that add up to negative 6? And remember, my dimensions are here. This is x and negative 1 and negative 1 and negative 1. We could write it that way, but negative 1, negative 1, and negative 1 are x and negative 3 and x and negative 3, because that square has dimensions that are the exact same. So this right here is the same as, and I don't have any room here, this would be right there. Okay, now you could leave it that way, but we want this in perfect square form, so recall that it's x minus 3 times x minus 3, that's x minus 3 squared equals 2. And ta-da, ding, 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 I have this in perfect square form. Bravo. Okay, but now let's talk about this, because how would we solve this, right? And the key is knowledge of solving is going to provide a lead into our next step here. I would need to get rid of that square root. I'm sorry, I said I would need to get rid of the square root. I meant I need to get rid of the square with a square root. I would need to square root here, and if I do it to the left-hand side, I would do it to the right-hand side. So this and this would cancel, and that probably makes sense to you. That probably makes sense. But recall, there are two numbers that multiply to be 2 when you square them. The positive square root of 2 and the negative 1. So if I was going to do this, I'd have x minus 3 on the left, but then over here on the right, my answer could be the square root of 2, or it could be the negative square root of 2. Now, those things alone by themselves aren't the solution. I still need to get rid of that 3. But recall that there's some duality there. I'd have more than one possible option, because squaring both of those things still gives me 2. Okay, let's use that to lead into the next thing that we're talking about, and that is this idea that's presented here in 9-13. Now, I've modified this question slightly for the purposes of our video today, and I'm going to change the color so this question stands out. One way to calculate the roots or the solutions of a parabola, the roots of a parabola, the solutions of an equation, is by using the quadratic formula, and it uses values of a and b and c from our quadratic equation written in standard form. This is super duper important. It's got to be written in standard form, which means that it's equal to 0. It means that the x squared comes first, the linear x term comes second if there is one, and then of course the constant comes third again if there is one. Okay, then we need to identify a, b, and c. Now a, b, and c go alphabetical order. The a is the number in front of the x squared. The b is the number in front of the x. And finally, the c for constant, is our non-x term. It's our term without a variable. Again, in standard form, it's got to be equal to 0. I always like to write these things down. So I will start every single quadratic formula problem by writing these things. A is, do you see it? It's not there, but do you see that it's 1? Right? We often don't write a coefficient of 1, but a is 1. B, and this matters, b is -3, right? Don't forget that sign. It is super important. And finally, c is, of course, -7. Now, once you've made it this far, believe it or not, some of the hard work is done. Okay? You are going to then take this handy-dandy tool, this quadratic formula, and you are going to plug things in. And if you plug things in correctly, you can then just follow your order of operations on the way to a perfect, exact, or approximate solution for the quadratic equation. Here we go. I'm going to start by writing it, and I'm going to start by writing it, and I'm going to take it slow. Okay? X is equal to -b. Now, b is already negative, so it's going to be a negative. And I know it looks silly to write it that way. We'll simplify it in a second. Okay, this is our plus or minus piece. This was what we investigated in the last problem. I could have a positive value or a negative value. There's my duality there. Okay, the square root of, right, we saw the need for that in the last problem, b squared, which is -3 squared, I do have parentheses there, minus 4 times a, which is 1, times c, which is -7, and I'll just put that in parentheses so we can keep that straight. And then it is all divided by, now I'm carrying that division bar under the entire thing, 2 times a, which is 2 times 1. Okay? Setup is so important. Setup and organization, so important here. Take your time, make sure this is done right. Okay? A -3 is a +3, plus or minus the square root of 3 squared and -3 squared both turn out to be 9. Here's where we've got to follow these order of operations. -4 times 1 times -7. That turns out to be a +28. And then this whole thing is divided by 2 times 1, which is 2. We are just about done. Believe it or not, I know it looks ugly, but we're just about done. I'm going to go ahead and I'm going to drag it up here. X is equal to, again, let's keep our work, organized. The square root of 9 and 28 makes the square root of 37 divided by 2. And here's where you could probably leave your answer. Okay, 37 we know is not a perfect square because 36 is a perfect square. Square root of 36 is 6, square root of 37 is 6 point something. So if your teacher tells you to go ahead and round it with a decimal approximation, go ahead and do so. But I would tell my students to leave this as 3 plus the square root of 37 divided by 2, or, right, 3 minus the square root of 37 divided by 2. Okay, and there is our 2 solutions to our quadratic equation. And we can confirm this graphically. And if we do decide to do that, we will see a decimal approximation. Desmos, or your graphing calculator, will not represent your solutions with those radicals. Okay, let's tackle one more of these. I'm going to show you an example where we do not have an integer, a coefficient of 1 on the for the a value, and I'm going to do so with letter B here. Letter B, I've got an a value of 2, I've got a b value of -9, and I've got a c value of -35. Now this is already equal to 0, so I'm already in good shape. Let's tackle B here. A is 2, B is -9, and C is -35, okay? If you would like to, go ahead and pause the video and set this up, okay? If you have the quadratic equation, go ahead and do so. Try to set it up with the quadratic equation. I've got the quadratic equation memorized. Maybe you do, maybe you don't. But I'm going to pause the video here. I'm going to write it down, and then we're going to check and see how you did. But I encourage you to pause the video, try to set it up as well. Okay, how'd you do? Did you get set up? I didn't simplify anything yet. I'm going to simplify with you right now. Okay, we've got a -9, which turns out to be a +9 plus or minus the square root of -9 squared is 81 minus 4 times 2 times -35. That's going to be subtracting a negative. 2 times 35 is 70. 4 times 70 is 280. So that's going to be a pretty big number. Divided by 2 times 2 on the bottom, which is 4. All right, we're getting pretty gosh darn close to being done here. X equals, right, carrying my work over, 9 plus or minus the square root of, I need to ask myself, what's 81 and 280? And this ends up being 361 divided by 4. On the last one, I did not turn this into a radical. So I'm just going to do that here. I'm going to do that on this one. I've got my handy dandy iPhone calculator. And if I turn this thing sideways, I get that radical symbol. So I will go ahead and I will type in 361, and I will take the square root of that thing, and voila. It's a pretty nice number. So that turns into 19. I've got X equals 9 plus or minus 19 divided by 4. Now, because these are integer values, we don't want to leave this. Let's go ahead and break this apart into 9 plus 19 divided by 4, or 9 minus 19 divided by 4. Okay, so 9 plus 19, do that. That works out to be 28. 28 divided by 4 works out to be 7. That should be one of my solutions. We'll check it together in a second. 9 minus 19 works out to be -10. -10 divided by 4 is -2.5. Okay? Here's what I'm going to do. I'm going to pause this video, and we're going to check it graphically. Okay, remember our solutions were 7 and -2.5. What did I do? I opened up a tab in Desmos, I typed in our equation, but instead of using 0, I set it equal to y. And then what did I do? I looked for those roots. There's -2.5, there's 7. That means we nailed it. Ladies and gents, a tiny bit of review preview here for you. 17, 18, and 19. Give these things a shot so we know what questions we have. Thanks for watching. Have a